Welcome back. All right, so we're going to solve all these problems using both methods, quadratic formula and completing the square. Right? All right, so quadratic formula, let's write the formula. So, and first of all, it is in standard form. Right? And let's write A, B, and C too. So what happened to A? A is equal to 1, B is equal to 3, C is equal to -1, right across, x squared, x, and our constant. Right, so quadratic formula, x is equal to -b plus or minus the square root b squared minus 4ac, all divided by 2a. So we have -3 plus or minus 3 squared minus 4 times 1 times -1, all divided by 2 times 1. So that gives us -3 plus or minus 9, and then this is two negatives, that's going to be plus 4 divided by 2. So we have x is equal to, this is going to simplify, -3 plus or minus the square root of 13 divided by 2. It's fine to leave it like that, or you could write x equals -3 plus the square root of 13 divided by 2, x equals -3 minus the square root of 13 divided by 2. On this problem, I don't care if you do that, so long as on a problem like this where it's not going to simplify any further, so long as you have the plus or minus there in the answer as part of the answer, that's fine. All right, or you can split it into two answers. I don't care on this one. It's when you can simplify it that you really need to split those, or when you can simplify them and they turn out to be real rational numbers. All right, so now let's try completing the square with this one. All right, so our first step, and so A is 1. We don't have to worry about that. So we're going to add 1 to both sides. Actually, I'm not even going to write that step in. I think we can add 1 in our head, right? So that we have x squared plus 3x. If I add 1, this is going to be equals 1. All right, so now I need to add b divided by 2 squared to both sides. That's going to be 3 divided by 2 squared, right, which, write that over here, x squared plus 3x plus 3 divided by 2 squared equals 1 plus 3 divided by 2 squared. Of course, 3 divided by 2 squared, that's 9/4, equals 1 plus 9/4. Right? On the left-hand side, that's going to factor to x plus the very thing you have right there. Right? That's what half of b is. It will always factor to x plus or minus, whatever that sign is. Right? And you'll have two of them, so it'll be square. Excuse me. Let me say that again. X, whatever that sign is. Right? If it's a plus or it's a minus, in this case it's a plus. And then b divided by 2. And since there's two of them, squared. I think I had forgotten to say the b divided by 2 part. I was just talking so fast. All right, so we have x plus 3 divided by 2, all squared, equals. We need to change that 1 so that it has the same denominator as 9/4. So that's going to be, hello, there it is, 4/4 plus 9/4. Right, so now we have x plus 3/2 squared equals 13/4. How come I'm writing and it's coming up so much faster? I mean, I'm writing and it's coming up so much slower than my words. X plus 3/2. I'm writing and nothing's coming up. And over on this side, we have to remember to take positive and negative square root. Let's split that into 2, right? Because it's a quotient, and I can simplify the denominator. If I could simplify the denominator, I'd be stuck rationalizing it. Maybe we'll look at a problem like that. So square and square root cancel. We have x plus 3/2 equals. Can't do anything with the square root of 13, but the square root of 4 is 2. Our last step is to subtract 3/2 from both sides. So come on, plus or minus the square root of 13. Exact same answer. They look a little different, right? This one to this one. But it's the exact same answer. Right? So if you're taking a multiple choice test and you'd use completing the square and that's your answer, you know you'll just have to combine the -3 and that square root of 13 and make that one fraction. Right? And they both have a denominator of 2. If you use quadratic formula and you see this one here as your solution, right? You'll know that you just need to split your fraction. Each term gets a 2, right? Each one is divided by 2, right? So you should be able to go back and forth to either one. In terms of you solving, I don't care which way it looks. They're both correct answers, right? And so here is our first one. It probably took a couple extra steps maybe for completing the square. I tend to have to make more errors though with those double negatives if I'm not really paying attention, because you can kind of go into automatic pilot mode, right? Neither one of these was too difficult, right? Because on the completing the square side, it follows a pattern. On the quadratic formula, we used a formula, right? Sometimes one is clearly better than the other. I call this one pretty much a draw. Neither one was that difficult. Here we have this one, right? 2x squared plus 3x equals 4. All right, well, we're not in standard form, so we're going to have to subtract 4 from both sides. All right, so over here we have 2x squared plus 3x minus 4 equals 0. Now a is 2. Oops. I said 2. Why am I writing a 1? A is 2, b is 3, and c is negative 4. Right, so x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. Right, so we have x equals negative 3 plus or minus 3 squared minus 4 times 2 times negative 4 divided by 2 times 2. Got another double negative there, so you gotta watch those. Negative 3 plus or minus 9 plus, so that's going to be 4 times 2, negative 4 times 2 is negative 8. Negative 8 times negative 4 is going to be a positive 32. Divided by 4, again we don't have one that's going to simplify. X equals negative 3 plus or minus, need more of these that simplify, 41 divided by 4. All right, let's look at the side. All right, well, we've got our constant over, but a is not 1, so we're going to have to divide everybody by 2. So x squared plus 3 halves x equals 2. Now we're going to add b divided by 2 squared. This time our b is 3 halves. So that's going to be 3 halves. Dividing by 2 is the same as multiplying by half. So that's going to be 3/4 squared. So we have x squared plus 3 halves x plus 3/4, because that's what half of 3 halves is, squared, equals 2 plus 3/4 squared. Boom. And so we have x squared plus, 3 halves x plus, so square the 3 and we'll square the 4. That's going to be 9/16. Equals 2 plus 9. So over on the left-hand side here, that's going to factor to x plus half of 3 halves was 3/4, the thing we squared. So x plus 3/4 squared equals, we need a common denominator, so 2's got to have a denominator of 16. So I got to multiply 2 by 16. That's going to be 32 plus 9 divided by 16. Take the square root. X plus 3/4 squared equals, let's add it together first. Then we'll take the square root. X plus 3/4 squared equals 41/16. Now we'll take the square root of both sides. So we have x plus 3/4 squared equals, let's split it, plus or minus, square root of 41 divided by the square root of 16. And so square and square root will cancel. We have x plus 3/4 equals, plus or minus, square root of 41, that's not going to simplify, it's a prime number. And square root of 16 is 4. All I got to do is subtract 3/4 from both sides. X equals negative 3/4 plus or minus square root of 41/4. All right, so not really that bad, almost a draw, except you maybe didn't really want to work with the fractions, maybe you struggle a little bit with that, but other than you have to just know what half of 3 halves is, remember the pattern for factoring, and just remember to get a common denominator. It wasn't too bad, right? Maybe quadratic formula was a little bit easier just because of the fraction on this one, right? It wasn't too bad for completing this. So when you have so notice here we have an odd coefficient in front of x, right? So if you have an odd coefficient, especially if you have to divide by 2, and you end up with a fraction for your b value for completing the square, then maybe instead you'd want to do quadratic formula, right? But either of these worked out just fine. But this might be a case where maybe quadratic formula would be easier for you. So important, simplifying the results using quadratic formula. The quadratic formula often leads to expressions such as the one below. Notice how it is simplified. All right, so you've got 8 plus or minus the square root of 20 divided by 4. If you do not, no, absolutely wrong, you get nonsense, right, as an answer, because you're simplifying things that are added, and multiplication is not the inverse of addition, all right? Absolutely wrong to cancel terms that are added, all right? I can just show you with 4. You either cancel it from everybody or you cancel it from nobody. That's the way it goes. Now, we can reduce that 20. All right, so when we have we have something here, we have 8 plus or minus the square root of 20 divided by 4. Before you do anything, you simplify that square root of 20. All right, so square root of 20, right, that's 4 and 5, right? 4 is 2 and 2. I can make this a little neater, couldn't I? 4 is 2 and 2. 1, 2 comes out. 1, 2 is dropped when we take the square root. So 2 square roots of 5, right? Still wrong to cancel the 8 and the 4. You have to reduce the 2 as well. Notice the 2 is not evenly divisible by 4, right? So you're going to have to divide everybody by 2. So if you can't cancel it from all, you can't cancel it, right? So they're all divisible by 2. I can divide this one by 2 and I get 4. I can divide the 2 by 2 and I get 1. I can divide the 4 by 2 and I get 2. So the correct answer here, now put it over here. The correct answer when you're simplifying this was 4 plus or minus the square root of 5, I don't really need the 1, divided by 2. That is correct. I should put correct answer as opposed to the nonsense. All right, so all these other answers, they're all nonsense. All right, so you can't just cancel out the 8 and the 4. That's wrong. Whether you simplify the radical or not, you cannot cancel the 8 and 4 unless you can cancel the coefficient in front. Also wrong. You can't cancel numbers and radicals. All right, I can't go okay, divide everybody by 4. I got 2, I got 1, I got 5. Ha, it's 2 plus or minus the square root of 5. Wrong, wrong, wrong. No, see, that does not equals. Wrong, wrong, wrong. And you might think, why am I telling you over and over again? No, 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 wrong, wrong, wrong. They can't do that. That's not mathematically equivalent, right? The square root of 20 and the square root of a number and the number itself are not the same things, because too many students forget and they make that error on the simplifying. It's probably the number one error students make with quadratic formula is incorrect simplifying. The number 2 error that students make is with the 2 negatives, not forgetting that that's a plus, right? So careful on your simplifying, all right? You got to reduce it from everybody. Okay? Thanks for watching this podcast. We'll do some more problems using the quadratic formula in the next podcast. Bye for now.